Welcome to Solving Absolute Value Inequalities. Let's get started. We want to learn how to solve absolute value inequalities today. So let's review really quickly. Remember when we were solving equations, not the inequalities, but if we had the absolute value of x and it equaled a, and we split that into our two parts, x would equal a, and the negative of x would equal a, meaning x would be negative a. All right, so we'd get two different answers. And so our solutions would be both negative a and a. Well, now we're solving inequalities. So these are for all real numbers, for all positive real numbers. If the absolute value of x is less than a, okay, we're going to still, like we did with the equations, rewrite our absolute value as a disjunction. So x is less than a. Okay, so that's one of our answers. And the negative of x is less than a. So then you'd have to divide by -1, and you get x is greater than negative a. So when you plot that on a number line, right, we have a, and it's less than a, and negative a, and we're greater than negative a. And actually, yeah, those are open circles because we're not equal to. Okay, but we said that x is less than a, so anything less than a, and anything greater than negative a. So all of our x's would lie in between both of these numbers. Now if we had the absolute value of x is greater than or equal to a, so remember these are real numbers, then the absolute value of x, when we split it into our two parts, then x would be greater than or equal to a. That's one of our answers. So these would be closed circles, and it would go off this way. So all of our real numbers greater than or equal to a. And splitting it up again, negative x is greater than or equal to a. So divide by -1, and x is less than or equal to negative a. So that means our solutions would be here. Okay, so what you should be seeing is we still have the same steps as we did with solving equations. We're still isolating that absolute value part, and then we're still splitting it into our two parts and then solving. It's just now we have an inequality sign instead of an equation sign. So here are two things I just want you to consider. Remember with equations that if you had the absolute value of x plus 1 equals -2, then automatically you would have no solution, right? Because the absolute value of anything cannot be negative. So there's two things that kind of go along with inequalities. If we have the absolute value of 2x plus 2 is less than -1. We could also stop right here because the absolute value of anything can't be less than a negative number. So then our answer here would be no solution also. The second thing to think about is if we have the absolute value of 2x plus 2 is greater than -1. Okay, so the absolute value of something, we want it to be greater than a negative number. So that would be all real numbers. Right, because the absolute value of something should be positive. So it should always be greater than a -1. So any number you plug in here should give me a positive number, which would be greater than -1. So let's go ahead and do an example of solving an absolute value inequality. The first step, just like with the equations, is we isolate our absolute value part, which it is isolated over here. So then the second step is to split it up into its two parts. We have x minus 7 is less than 5, and then we have negative x minus 7 is less than 5. So these are the same steps as the equations, it's just we have an inequality sign. So on this side now we're solving for x. Add the 7 to both sides, so x is less than 12. And on the right, I'm going to distribute that negative in, or you could divide by the -1 if you'd rather do that. And then I subtract the 7, and I'm going to divide by -1. So you're going to divide by -1 regardless. It doesn't matter when. So I have that x is greater than 2. Remember, we flip the sign when we divide by a negative number. So what you want to do now, or what helps, is to use this number line. right? Just like we talked about before. So it's greater than 2, but it's less than 12. So it's got to satisfy both requirements. So greater than 2, it's an open circle because it's not equal to, means it's going this way, but it also has to be less than 12. So my x has to be somewhere in between 2 and 12. Those are where all my solutions lie. So here's another example. You can either stop and try it on your own and then come back and see if you did it right, or you can follow along. So this example is 2 times the absolute value of x plus 1 minus 10 is greater than or equal to negative 4. So we want to isolate the absolute value part right here. So we're going to add the 10 to both sides. I'm going to get 2 times the absolute value of x plus 1 is greater than or equal to 6. Then we divide by 2. And I have the absolute value of x plus 1 is greater than or equal to 3. That was the first step, isolating the absolute value. Then we can split up my parts. X plus 1 is greater than or equal to 3. And then negative x plus 1 is greater than or equal to 3. So on the left, now we solve for x. So subtract the 1, and I get x is greater than or equal to 2. So there's one of my requirements for my x. And on the right, you can, again, distribute that negative 1, or you can divide by negative 1 first. And I get x is less than or equal to negative 4. Okay, so x has to be greater than 2, greater than or equal to 2, and less than negative 4. I'm sorry, or less than or equal to negative 4. So the way that looks on a number line is if I have negative 4, here's positive 2. So it has to be less than negative 4, or it can be greater than 2, greater than or equal to. So my x's can either be over here or over here on the number line. All right, don't forget to write your summary and your questions. And that's all for now. See you soon.